This video walks you through the standard operating procedures for the FEI Quanta 650F ESEM. I will be going through the procedures quickly, so please feel free to pause the video at any time. This video will cover startup and sample loading, setting operating conditions, how to capture and save images, how to use the backscattered electron detector, how to use variable pressure mode, and how to shut down the instrument. The first thing you will need to do is begin your reservation in the Nucor system. Visit the nucor.northwestern.edu website and log in with your NetID credentials. Navigate to the My Reservations tab, and in the list of reservations, select the link that says Begin Reservation. Doing this will activate the main Quanta computer monitor and allow you to begin working. In order to load the sample, you will need to open the user interface and select the Vent button in the top right-hand corner. A window will pop up to confirm the venting process. Select Yes, and the chamber will start to vent. Once the chamber has vented, slowly slide open the chamber door by pulling on the handle at the base. Standard SEM aluminum pin stubs can simply be pushed into the sample stage. It is important to ensure that your samples are roughly the same height. The height difference should be no greater than 5 millimeters between samples. The Quanta will display an image of the stage on the user interface to help you navigate around your sample. To capture this image, swing the camera over the sample. The stage will center under the camera and capture one image. After the first image has been captured, press the button on the top of the camera and capture a higher quality image. Once the camera light turns off, you can swing the camera out of the way and close the chamber door. Hold the door closed to ensure a tight seal and pump down the chamber by selecting Pump on the user interface. You can see the chamber vacuum status at the bottom right-hand corner of the screen. It will display the chamber pressure along with a schematic. The chamber in the schematic will turn green when the chamber has pumped down all the way. The user interface displays 4 quadrants. Quadrant 1 is the live scanning window where your image will be displayed. Quadrant 2 is another live scanning window which allows you to scan using multiple detectors simultaneously. Quadrant 3 is the navigation image of your stage, and Quadrant 4 is a live video of the inside of the chamber showing the stage and the objective lens pull piece. In order to operate in a quadrant, you must select it. You'll know it's selected when it's highlighted in blue. Select Quad 1 and set your SEM operating conditions. In the top left-hand corner of the screen, there are a number of drop-down menus that allow you to change these conditions. You can select your accelerating voltage by clicking on the drop-down menu. Next, you will set your spot size. A smaller spot size will result in a higher resolution image, but it will decrease your signal due to a decrease in probe current. A larger spot size will provide more signal due to a higher probe current, but reduce your imaging resolution. For general imaging, we usually start at a spot size between 3 and 4. Next, you will need to set your objective aperture. You can change your objective aperture by turning the knob on the microscope column. Turn the knob until it's pointing towards the objective aperture size that you'd like to use. Smaller apertures, between 5 and 7, are generally used for imaging, whereas larger apertures, 1 to 4, are used for maximizing probe current for analytical techniques. You can also change your accelerating voltage and spot size in the beam control panel on the right-hand side of the user interface. Once those conditions have been set, you can turn the beam on by selecting the Beam On button in the beam control panel. You will notice that the live scan window is not actively scanning. In order to begin scanning, you will need to unpause the screen by selecting the green pause button in Quad 1 or by selecting the pause button in the top tool panel. In the same panel, you can find a drop-down menu that will change your scan speed by changing the pixel dwell time. There's also a drop-down menu to change the pixel resolution of your image. Once you are scanning, you can adjust the brightness and the contrast of your image using the knobs on the knob set or by selecting the automatic brightness and contrast button in the tool panel. You can focus the image using the fine and coarse focus knobs on the knob set, or you can hold down on the right mouse button and slide the mouse back and forth. And finally, you can change your magnification by using the magnification knob on the knob set or by selecting a preset magnification at the bottom of Quad 1. You can select a preset magnification or you can type in a custom magnification by selecting Custom and entering the value. There are a number of ways to move around the stage to find your sample. You can double-click on the image in the navigation in Quad 3. You can double-click on the live scanning window to center on the object that you clicked on, or you can hold down on the middle mouse button and drag the mouse in the direction that you'd like to move. Move so that you are at the tallest point on the tallest sample and focus. As you focus, you will notice that the working distance is changing. The working distance is the distance of the sample from the final lens when the beam is in focus. If you open the Navigation tab on the right side panel and select Coordinates, you will see a list of stage coordinates. The value set for stage height, or Z, is set to 0 because the SEM currently doesn't know how tall your sample is. We can link the Z height to the working distance we determined by clicking on the Link Z button in the tool panel above Quadrant 1. Now that the Z height matches our focal height, we can move the stage closer to the pole piece. It is important to indicate to the SEM where your sample is to help prevent the sample from crashing into the pole piece. If you're not focused on the tallest spot before you link, the SEM might think that your sample is further away than it actually is. This increases the chances of crashing your sample into the pole piece. Once you have properly linked your working distance, type in 20 millimeters into the Z height. The stage will move up to 20 millimeters. Refocus and relink your working distance. Now you can move the stage up to 10 millimeters, which is the analytical working distance for the EDS system. You're welcome to change the working distance however you'd like depending on the analysis that you're performing. You can press the Escape key at any time on the keyboard to stop the stage from moving. Once you have centered over your sample and refocused, we can go through a series of alignments. Increase your magnification to at least 10,000 times and select the Reduced Area button in the tool panel. This provides a smaller scan window with a faster refresh time. Open up the Direct Adjustments menu in the tool panel. The Direct Adjustments panel allows you to perform alignments that fine-tune the beam geometry to achieve the best focus and brightness. We will start in the Beam tab with the Lens Alignment. The Lens Alignment will help remove any image shift during focusing by adjusting the beam position setting relative to the final lens aperture. If we turn on the Lens Modulator, you will see that the focus shift is exaggerated. You will see motion in the X direction, side to side, and in the Y direction, up and down. To reduce the up and down motion, select the horizontal line in the lens alignment and drag the line up and down. To correct the side to side motion, click on the vertical line in the lens alignment and drag the mouse side to side. Once you have corrected both the up and down and side to side motion seen in the image should look as though it's beating in and out of the screen. Now select the crossover button in the source tilt section. Ensure that the electron source tip image is centered around the green X. If you increase the spot size and the contrast, a bright source tip can be seen easily in the image. You can use the source tip crosshairs to move the bright spot into the center of the green X. Next, you will open the Stig Centering tab. This will help to minimize image shift during astigmatism correction. Select Modulator X and correct the translation seen in the image similar to the lens alignment. Once that has been corrected, select Modulator Y and do the same thing. You can now close out of the Direct Adjustments panel and start to refocus on your image. When you focus back and forth, you will notice that the image is being stretched in two directions. This is because the beam is astigmatic. We can fully correct for the astigmatism of the beam using our stigmators. First, focus the beam back and forth and identify the two stretch directions. Try to find the point in the middle where the beam is most circular and there is no stretching in the image. Once you have found that point, you can correct the astigmatism by turning the stig knobs on the knob set one at a time. When you turn these knobs, you are looking for the clearest image possible. Once you have found the clearest image, you have fully corrected your stig and you can start capturing images. To get out of the Reduced Area Scan, simply click the Reduced Area Scan button. Select the Image Acquisition button on the tool panel. To change the imaging scan speed, select the Scan menu, go to Preferences, click on the Image Acquisition in the list, and change the dwell time for your image acquisition. Now, when you press the Image Acquisition button, or F12, it will capture at this scan speed. Once the scanning has completed, it will prompt you to save your images. All images must be saved to the Quanta Epic SEM drive, or the S drive. All files must be created under the user's net ID. You can change the file type. You can also have the image save with overlaid graphics or with or without the data bar. To apply overlaid graphics, you can open the Processing tab on the right side panel. In the Processing tab, you can select the measuring tool and measure features in your sample, or you can draw shapes or add text. Some samples may benefit from using the backscattered electron detector. Backscattered electrons can show you compositional contrast in your image. If you open the Detectors panel, you will see a drop-down list with a number of detectors that you can use. The CBS is the concentric backscattered electron detector. Click on Quadrant 2 and select the CBS from the list. Before you insert the detector, make sure that your sample is at least 10 millimeters away from the pole piece so we don't crash the detector into your sample. Confirm and you will see the detector slide in under the pole piece. You can select your auto brightness and contrast button and then see a backscattered electron image. You can see now that we can collect a secondary electron image in quadrant 1 at the same time as we collect a backscattered electron image in quadrant 2. The concentric backscattered electron detector is a solid-state detector that is broken up into segments, or rings. High-angle backscattered electrons can be collected with ring A. This will show you more compositional contrast, while low-angle backscattered electrons will be collected with ring D. This will show you more topographic information. Using all rings will give you a lot of signal and provide a little bit of both types of information. When you are done with the backscattered electron detector, select the Retract button to remove it. If you have a sample in the SEM that is non-conductive and not coated, you will see a number of charging artifacts. This is because there is negative charge buildup on the surface of the sample. To image a sample that is not coated or not conductive, we can introduce some water vapor into the chamber. The primary electron beam, as well as secondary electrons and backscattered electrons emitted from the sample, will interact with the gas molecules and create positively charged ions that can fall down to the surface of the sample and neutralize any negative charge buildup. To use low vacuum mode, first turn off the electron beam. Select your chamber pressure from the drop-down list in the beam control panel. Next, select the low vacuum option. For now, we are not using an accessory, so we will select no accessory and click OK. You will see the chamber start to pump in the bottom right-hand corner of the screen. Once the chamber pressure has reached the pressure you selected, you will see the schematic turn green and you are ready to turn on the beam. Adjust your brightness and contrast, your magnification, and your focus. The low vacuum operations use a special large field detector. The large field detector can collect both backscattered and secondary electrons. If you'd like to know more about low vacuum operations and higher collection efficiency detectors, please talk to EPIC staff. Once you have finished your analysis, you can turn the beam off and vent the chamber. Once the chamber has vented, you can open the door using the handle and remove your samples. It is important that you always pump down the chamber before you leave. Once you have pumped down the chamber, you can end your reservation in the new course system. For more information, please visit nuance@northwestern.edu. In the EPIC section, you can find our contact information, a list of our instruments, and documentation and user manuals on all of our instruments. Thank you for watching this video.